In this part, I will explain how to use Python to solve the location selection problem. We need to prepare data first. Because the geographical location information of each device is spatially clustered, we need to extract the longitude and latitude information of each device from the raw data. Next, invoke the clustering method in the eLearning library of Python to perform modeling. The nCluster parameter indicates the number of clusters and is an important parameter in the clustering algorithm. Random state indicates the initial random number sequence specified during initial cluster center selection, which has little impact on the final test result. After that, we use the .fit method to invoke the model, and finally use the print statement to output the location coordinates of each center point. In the k-means clustering algorithm, there are several important parameters. The first parameter is nCluster, which specifies the k-value. The init parameter indicates the initialization method of the initial cluster center, and the k-means double plus method is selected by default. Maxiter indicates the maximum number of iterations. That is, the number of iterations during cluster calculation. Then I will show the code on Huawei Cloud Model Arts Developer Platform. After logging in the console, choose EI Service and choose Model Arts. Then click the DevEnviron Notebooks. You can create a new notebook. For we have created one. We use it directly. Do remember, you need to sysc the data on notebook. At first, we need to import the common packages, such as pandas and eLearning packages. Then read the data required by this course, the details. CSV file generated in the previous test. After that, extract the data required by this test. That is, the longitude and latitude information of each device. Before modeling, we need to process the data format. The clustering method in eLearning requires that the input data format be multi-dimensional array. Therefore, we need to extract the longitude and latitude values from the .from format and convert them into the multi-dimensional array format. Next, invoke the k-means method in eLearning to cluster the model. Here, set the number of clusters to 3 to create a model. After the modeling is complete, import silhouette coefficient in the eLearning metrics package to evaluate the clustering effect. Import the required package and use the silhouette underline score method to calculate the effect of the cluster model. The evaluation result is 0.46. After a model is established, it cannot be determined that the k-value is the optimal value. You can change its parameter, such as the number of clusters, to compare the model effects of different k-values. We tried to cluster into 2 clusters, 4 clusters and 5 clusters, and printed the evaluation result of each model. Compare the model evaluation results. The result shows that when the number of clusters is 4, the model evaluation result is the best, if the construction cost is sufficient. 4 distribution warehouses are recommended. At last, we print the output of the clustering model. The k-means algorithm outputs 3 results: the coordinates of the cluster center, the label of each cluster, and the distances from each point to the centroid of the cluster. The sample labels and prediction values in the first 5 rows are output. Centers indicates the coordinates of the 4 cluster centers. That is, the coordinates of the 4 distribution warehouses. To make you understand the clustering result intuitively, we use this code to display the clustering result. We can see that the geographical location information of devices in Zhejiang is divided into 4 clusters. Finally, let's review the main content of this course. In the first part, we learned about the main factors to be considered and some common solutions when selecting the location of distribution warehouses. In the second part, we have learned common clustering algorithms and their calculation principles. There are several main categories of clustering methods. The first category is partitioning clustering. And typical algorithms include k-means and k-medians. Another category is hierarchical clustering, which performs clustering in top-down and bottom-up modes. The third one is density-based clustering, and a typical algorithm is deconstruct. The three methods have their respective comparative advantages. In the last part, we learned how to evaluate the clustering effect. The evaluation indicators include external indicators and internal indicators. We introduced internal indicators in detail in the code demonstration. We also introduced how to use silhouette coefficient to evaluate the clustering effect.